Okay, in this lesson we're looking at Unit 6, Chapter 6. We're looking at trigonometric identities. We're going to continue with the sum, difference, and double angle identities. This is Part 2. And we're going to be determining the exact values using sum, difference, and double angle identities. So again, this is from Section 6.2 in your book. And the focus is going to be on determining exact values using sum, difference, and double angle identities. As a quick reminder, your double angle identities are here, your difference identities are these here, and your sum identities are here. Of course, you still need to remember that we do have the Pythagorean identities that we learned earlier, and these are the ones located here. Again, all of these identities will be given to you on your public exam, so it's not something you need to memorize. You just need to be able to apply them. I'm not going to go through them individually, again, because they're all going to be given to you, and you should have some recollection of these at this point. Let's start applying these to examples like you see here. Determine the exact trig values for angles. So, for example, determine the exact value for each. The sine of pi over 12. If I want to determine the exact value, very important word here, determine the exact value of the sine of pi over 12. Well, first of all, I'm not 100% sure of what pi over 12 is. So what I normally do in this case, when I'm asked to find the exact value of something like pi over 12, I want to change it to degrees first. Then I'll change everything back to radians afterwards. That's just the approach that I normally take. So for example, I'm going to take my pi over 12, I'm going to change it to degrees by multiplying by pi over 180, 180 over pi. And when I do that on the calculator, I'm going to get 180 divided by 12, which is equal to 15 degrees. So I now know I'm really looking for the sine of 15 degrees. So what I think about then is, how can I rewrite the sine of 15 as the sum or difference of two numbers? So for example, I can write this as the sine of 45 subtract 30. 45 subtract 30 is 15 degrees. Now, why would I use 45 and 30? Well, it's because I know how to find the exact value of both 45 and 30, whether it's sine or cosine, it doesn't matter. But I can now find the sine of 45 subtract 30 because they're exact values. I know how to do that. And I'm looking for the exact value, you see. So I'm going to go back now and I'm going to rewrite this in terms of radians because it is a radian question. So I'm going to rewrite that as the sine of 45, which is pi over 4, subtract 30, which is pi over 6. So in actual fact, pi over 4 subtract pi over 6 is pi over 12. To come up with that directly from here, I think is a little difficult. That's why I decided to change it to degrees first and then rewrite it back in terms of radians. So I get the sine of pi over 4 subtract pi over 6. So I'm going to use my identity for sine, A subtract B. It's a difference identity for sine. It's sine A cosine B subtract cosine A sine B. So let's fill that in. I got the sine of pi over 4 times the cosine of pi over 6 subtract the cosine of pi over 4 times the sine of pi over 6. All I need to do now is simply fill those in and simplify. The sine of pi over 4 you should know is root 2 over 2. The cosine of pi over 6, well, pi over 6 is 30 degrees. So again, you should know at this point that the cosine of pi over 6, being a reference angle of 30 degrees, the cosine is root 3 over 2. Subtract the cosine of pi over 4. Cosine of pi over 4 is root 2 over 2 as well. Times the sine of pi over 6. The sine of pi over 6 is 1/2. And again, I got that from my unit circle. Just think about, again, your unit circle if you need to. A reference angle of 30 degrees. The point associated with that reference angle of 30 degrees is root 3 over 2 and 1/2, or in other words, pi over 6. And you should know pi over 4 is root 2 over 2 and root 2 over 2 as well. Okay, now all I need to do is simplify. I got root 2 over 2 times root 3 over 2. That's root 6 over 4. Subtract root 2 times 1 is root 2 over 4. I got a common denominator of 4, so I simply rewrite this as the root of 6 minus the root of 2. And there's my answer for the sine of pi over 12 as an exact value. It's root 6 subtract root 2 over 4. Okay, in a similar way, I can find the exact value of the tan of 105. again, I need to think about two values that I can either add or subtract to give me 105 that I can find the exact value of. So we need to think of two numbers. Let's think. 135 subtract 30 will give me 105. That'll work. Or I can do 60 plus 45. That will also work. 60 plus 45 is 105, or 135 subtract 30 is 105. Either of these will give me the exact value for the expression. I'm going to use plus this time, only because I used subtract the last time. That's the only reason why. I use subtraction here, so I'm going to use plus here. I'm going to rewrite this as the tan of 60 degrees plus 45 degrees. So because I'm using tan of A plus B, here's the identity I'm going to use up right here. So I'm going to rewrite that now as a tan of 60 plus the tan of 45 divided by 1 subtract tan of 60 times tan of 45. Okay, again, we're looking for exact values, so we need to find the exact value of each. Tan of 60, tan of 60, tan is sine over cosine. So again, let's draw a unit circle here, just as a reminder of what we're referring to here. So I just draw a unit circle down here in the corner. 60 degrees, reference angle of 60. We should know that the point associated with that reference angle of 60 degrees is 1/2 root 3 over 2. We're looking for the tan of 60. The tangent of 60 is equal to the sine of 60 over the cosine of 60. The sine of 60 over the cosine of 60. Don't want to run out of room here, but you want to think about that as root 3 over 2 divided by 1/2. Root 3 over 2 divided by 1/2, the 2's will cancel, and I'm simply left with root 3. So the tan of 60 is root 3. Plus the tan of 45. Now 45 degrees, and I'll just go up right here and draw another unit circle. 45 degrees, the point associated with that is root 2 over 2 and root 2 over 2. Tan is sine over cosine, which is going to be root 2 over 2 divided by root 2 over 2, which is 1. So I'm simply left with root 3 plus 1 in my numerator, divided by 1 subtract root 3 times 1. So I'm left with the root of 3 plus 1 over 1 minus the root of 3. Now we know we don't need a radical in the denominator. So we need to get rid of the radical here by multiplying by the conjugate. So I'm going to multiply by 1 plus root 3 over 1 plus root 3. And whatever I get is going to be my final answer here. Now remember, when I'm multiplying the numerator, I got to use the distributive property here. And I'm going to get root 3 plus root 3 times root 3 is 3, plus I got a 1 plus root 3. I'm going to double check that now. That's root 3. That multiplied together is 3. That multiplied together is 1, and 1 times root 3 is root 3. Divided by, using distributive property again, I get 1. Subtract root 3, plus root 3, subtract root 3 times root 3, which is 3. Again, all I'm using is use distributive property there, not too difficult. So my numerator becomes 4 plus 2 root 3 over 1 subtract 3 is a negative 2. I can rewrite my numerator by removing a common factor of 2, and I would say 2 outside of 2 plus root 3 over a negative 2. The 2's cancel. I'm left with a negative 1 in the denominator. If I bring that negative 1 to the numerator, I'll get a negative 2, subtract root 3, and there would be my final answer for the tan of 105. Negative 2 subtract root 3. Again, I took the negative 1 from the denominator here, and I simply brought it to the numerator and multiplied it in through. Negative 1 times 2 plus root 3 is a negative 2 subtract root 3. And that is the exact value of the tan of 105. Okay, let's move on to another example here. This is a multiple choice question. You may want to pause the recording at this point and try this one on your own as well. At this point, Okay, let's do this. I have 4 times the sine of pi over 8 times the cosine of pi over 8. Now, looking at that, you may not recognize that as being any particular identity. But notice that we have the same value here of pi over 8. So it looks something like sine A times cosine A. Now, I don't have an identity for sine A times cosine A, but I do have an identity for 2 sine A times cosine A. And here it is over right here. 2 sine A cosine A is equal to sine 2A. Now, how can I rewrite this using 2 sine A cosine A? Well, if I were to rewrite it as 2 times 2 sine pi over 8 times the cosine of pi over 8, it now becomes 2 times 2 sine A cosine A, which is sine 2A. So it's sine 2A, which is pi over 8. So it becomes 2 times the sine of 2 times pi over 8 is pi over 4. Evaluating the expression as an exact value, the sine of pi over 4, you should recognize the sine of pi over 4 is going to be root 2 over 2. Root 2 over 2 times 2 is simply root 2. Final answer is B. Again, I had to use my double angle identity for sine for this one. I had to rewrite the original expression as 2 times 2 sine pi over 8 cosine pi over 8. Example 3, which is equivalent to the sine of negative 5 pi over 6 subtract 2 pi over 3. Again, we're looking for an exact value here. Might be a good idea for you to pause the recording again and try it on your own. But let's do it. Sine of A subtract B is what we're going to use here. Because you can see that's exactly what I have, A subtract B. So if I substitute this in, I get sine A, so it's the sine of negative 5 pi over 6, times the cosine of B, which is the cosine of, now it's not negative 2 pi over 3, it's 2 pi over 3. Because remember now, A is negative 5 pi over 6, subtract B, which is 2 pi over 3. Be careful with your signs here. A is this, B is this. Subtract the cosine of A, which is a negative 5 pi over 6, times the sine of B, which is 2 pi over 3. So, of course, I need to evaluate each of those individually. So we're going to draw a couple of unit circles here to help us do that. We'll draw a unit circle here, and we will, first of all, rotate negative 5 pi over 6. Negative 5 pi over 6 rotating in the negative direction. This is negative 6 pi over 6, so I'm 1 pi over 6 less than that. So my angle is going to be somewhere around here, negative 5 pi over 6. Pi over 6 is 30 degrees. So because pi over 6 is 30 degrees, my reference angle here is 30. So I got the points negative root 3 over 2 and negative 1/2. And let's do the other one, 2 pi over 3. 2 pi over 3 is approximately located here, because again, this is 3 pi over 3. I'm 1 pi over 3 less than that. Pi over 3 is a reference angle of 60 degrees. So the coordinates of this point is going to be 1/2 and root 3 over 2. And of course, in this quadrant, x is negative and y is positive. Whereas in the first one, both were negative. Okay, now that I got my two unit circles drawn, I should be able to easily find the sine and cosine of the angles that I need. The sine of negative 5 pi over 6. Sine is the second coordinate, so it's negative 1/2. Negative 1/2. Times the cosine of 2 pi over 3. Cosine of 2 pi over 3. Cosine is the first coordinate, negative 1/2. Subtract the cosine of negative 5 pi over 6 is a negative root 3 over 2 times the sine of 2 pi over 3, which is a positive root 3 over 2. All I need to do is simplify this. Negative times a negative is a positive, 1/4. Subtract a negative 3 over 4. Root 3 times root 3 is 3, 2 times 2 is 4. So I got 1 over 4 plus 3 over 4, which equals 4 over 4, which equals 1. Correct answer is D. Example 4. What is the exact value of cosine of 5 pi over 12? Again, what we want to do with this one is we want to rewrite this, think about it in terms of degrees first, then go back and rewrite it in terms of radians. Again, you may want to pause the recording and try this one on your own first and see if you can get one of these answers here. But let's do it. Cosine of 5 pi over 12. 5 pi over 12, let's see what that is in degrees first of all. Let's multiply by 180 over pi, and I'm going to get, on my calculator, simply 5 times 180, pi's will cancel of course, divided by 12, and I get 75 degrees. So I'm really looking for the cosine of 75. The cosine of 75 can be written as the cosine of 45 plus 30. And again, I want to think about two values that I can either add or subtract that will give me 75 degrees, but the two numbers that I'm adding or subtracting, I can find the exact value of. I can find the exact value of cosine and 30. Doesn't matter what I'm looking for, cosine or sine. Okay, now let's go back and rewrite in terms of radians. So this is really the cosine of 45 degrees is pi over 4. 30 degrees is pi over 6. So I'm looking for the cosine of pi over 4 plus pi over 6. Now we need to use our identity for cosine. I didn't put that one up in the corner, but I'll write it in for you now. The cosine of a plus b, I'll write it down here I guess. The cosine of a plus b, all I'm doing is looking at my formula sheet to get that, is equal to cosine a times cosine b, subtract, very important, sine a times sine b. Okay, so in this case we're filling in cosine of pi over 4 plus pi over 6. So we end up getting cosine pi over 4 times the cosine of pi over 6, subtract the sine of pi over 4 times the cosine of pi over 6. Again, we need to be able to find the exact values of each of these now. You should remember that cosine pi over 4, root 2 over 2. Cosine of pi over 6 is the same as 30 degrees. 30 degrees has a reference angle. Sorry, with a reference angle of 30 degrees, the point is root 3 over 2 and a half, so we got root 3 over 2. Subtract the sine of pi over 4, which is again root 2 over 2, and the cosine of pi over 6, I think I've made an error there. Yes, sorry, I have. I immediately knew I did because when I saw the cosine of pi over 6 twice, I said I got an error made here. So let me fix that before we go any further. And the error is I wrote cosine there that's supposed to be sine, isn't it? It should be the sine of pi over 6. Sorry for that. The sine of pi over 6. Okay, so the sine of pi over 6, 30 degree reference angle. Again, if you need to draw it, you can do that. Reference angle of 30 degrees. You should recognize the point is root 3 over 2 and a half. So we're looking for the sine. Sine is 1/2, isn't it? Second coordinate. Now I think we're okay. So I got root 2 times root 3 is root 6 over 4. Subtract root 2 over 4. That would simply become root 6 subtract root 2 over 4. Look for the answer. Root 6 subtract root 2 over 4. Correct answer is C. Okay, let's have a look at one more example here. If sine A equals 4 over 5, and A is between pi over 2 and pi, determine the exact value of sine 2A, cosine 2A, and tan 2A. Now I wrote all of these down in the bottom here for you. Now of course we're going to do the cosine of 2A. We don't need to do all of these. We just choose one of these to do. But we need to recognize that this is located in a certain quadrant. So in this case, we know that the A, being the angle itself, is between pi over 2 and pi. So we know that our angle A is located in the second quadrant. So here's A right here, angle A, between pi over 2 and pi. We know that the sine of A is 4 over 5. We know that we use the reference angle to help us determine all the sides here. So sine theta, we know that the sine of A is equal to the opposite over the hypotenuse. So the opposite side in this case is 4, the hypotenuse is 5. Opposite side is 4, the hypotenuse is 5. The adjacent side you should recognize immediately as being 3. If you don't recognize that, of course, you can use the Pythagorean theorem to determine the adjacent side. Right? X squared plus 4 squared equals 5 squared. Solve for x, you'll get 3. Most of you should recognize the triangle 3, 4, and 5 at this point. So I know the adjacent side. Now we need to determine the exact value of the sine of 2a, cosine 2a, and tan 2a. Let's do that. Sine 2a is simply 2 times the sine of a times the cosine of a. So that simply becomes 2 times the sine of a, well that's 4 over 5. That's given. Sine of a is given. Times the cosine of a. The cosine of a is the adjacent side of the hypotenuse. And by the way, that's a negative 3 here, isn't it? Right? Negative 3 because we're in the second quadrant. Okay, be very careful there. So the cosine of a is going to be the adjacent side of the hypotenuse, which is negative 3 over 5. When I multiply the two together, I'm going to simply get negative 24 over 5. So the sine of 2a is negative 24 over 5. Let's do the cosine of 2a. Cosine of 2a, again, I just need to choose one of the three that you see below here. Doesn't matter which one I choose. I'm going to choose, because I'm given sine, okay, I'm going to choose this one. 1 minus 2 sine squared a. So I'm going to do 1 subtract 2 times the sine of a, which is 4 over 5. You see, that's why I chose that one, because it was already given to me, squared. So that gives me simply 1 subtract 2 times 16 over 25, which gives me 1 subtract 32 over 25. Put this over 1, and I get 25 over 25 subtract 32 over 25, which will give me a negative 7 over 25. Cosine of 2a is negative 7 over 25. I'm just going to double check my calculations here. Sine squared a is the same as sine a squared, by the way. So I took the sine of a, which is 4 over 5, and squared it to give me 16 over 25. Times it by 2, I get 32 over 25. 1 subtract that, and I'm pretty sure I'm correct at negative 7 over 25. Okay, the last one here is the tan of 2a. The tan of 2a, here's my formula for the tan of 2a. This one might require a little more work. Tan 2a is equal to 2 tan a over 1 minus tan squared a. Okay, now we need to figure out what the tan of a is, of course. The tan of angle A is equal to opposite over the adjacent side. The opposite side is 4, the adjacent side is negative 3. So the tan of A is actually negative 4 over 3. Negative 4 over 3. Or 4 over negative 3, but again, we normally put the negative in the numerator or in front of the fraction. So I got 2 times negative 4 over 3 divided by 1 subtract negative 4 over 3 squared. So again, it's pretty simple math from here on in. You should be able to do this without too much difficulty. I'm going to get negative 8 over 3 divided by, I'm going to get 1 subtract 16 over 9, which becomes negative 8 over 3, hopefully one in the room here, negative 8 over 3, divided by, I'm going to rewrite that as 9 over 9 subtract 16 over 9, which becomes a negative 8 over 3 divided by 9 subtract 16 is a negative 7 over 9. All I need to do now is multiply by the reciprocal. So let's go where to finish that? Let's go up right here to finish that, okay? Right up here. So I got a negative 8 over 3 times a negative 9 over 7. That's going to give me 9/8 is 72 over 21. And this does reduce, and it's positive, by the way. So 72 divided by 3 is 24. 21 divided by 3 is 7. So I get 24 over 7 for my final answer for the tan of 2a. Okay, again, key ideas. And this is exactly what we did here in this lesson. We use the sum of different identities to simplify expressions and determine exact values, right, for some angles. We looked at a number of different angles. We found the exact values of them. Again, there's your sum of different identities. And we also use the double angle identities to do the same thing, right? And we use double angle identities to also determine the exact trig values, right? And that ends this lesson.